All right, and here are the lesson 1.5 measure and classify angles notes. So you can kind of see we got a pretty good amount to get through, a little bit longer of a lesson here. We'll go through all the different ways to name, measure, and classify angles. What is an angle? Talk about some of the different parts of it. Talk about congruent angles. Get into some postulate. We'll talk about what's called a protractor postulate and the angle addition postulate, and then this idea of angle bisector. So this really relates back. It's really connected to some of our early lessons, 1.1 and 1.2. We did a lot with segments and midpoints of segments and segment addition postulate. Now we're just talking everything today is angles. So it's kind of a combination of our first lesson 1.1 and 1.2, except extending those ideas really to angles, okay? So let's get into it. Some of the vocab about an angle. What is an angle? Like definition-wise, it's essentially two different rays with the same endpoint. Okay, so we've talked early on about rays. So for our particular angle right here, I've got a ray BA, right, starting at B, going forever through A, starting at B, going through forever through C. So I've got ray BC. There's my angle. Okay, the different parts of the angle are what we would call the sides. So here's a side, and here's a side, and those essentially are rays. Okay, so the two rays that form that angle are what we would call sides. So that's a vocab word for us, the sides of an angle. So if I asked you to name the sides of an angle, for our particular picture here, we would say ray BA is one of our sides, and ray BC. Okay, so if you're ever asked to identify the sides of an angle, don't say side A or side C. We name them using the rays. Okay, vertex. All right, the vertex of our angle is that common endpoint that the rays are sharing. So for us, we would say if I asked you to identify the vertex of this particular angle, we would say point B. All right, and that would be our vertex. All right. The last thing is, how do we've talked a lot of different we've talked about a lot of different figures that we name and specifically have to talk about in certain ways, saying point B. Here's two perfect examples, point B and rays BA and BC. All right, those symbols are meaningful. How many letters I'm using are meaningful. Same thing applies to an angle. So this particular angle, there's really a couple different ways we could talk about an angle. So the first way would be to use 3 points. Okay. A point on each side. On each side. So there's two of the 3 points. So for us, we could talk about point A and point C as being two of those 3 points. The key is the vertex is also what we want to use. That's my third point. So a point, and the vertex. Vertex must be in middle. All right, so for us, the example would be, this could be called angle ABC. All right, so we say that word angle just like we say the word ray, just like we say the word point. Don't just say ABC. Angle, and I've picked a point on the side A, I put my vertex in the middle, and then I've got a point on the other side. We could also call this angle CBA and still be correct as far as using a point on each side. So you don't have to go top to bottom, left to right. As long as you pick a point on each side and get that vertex in the middle, you're okay. Abbreviation-wise, this same thing could be said or written really as angle ABC. So to replace that word and to avoid having to write the word angle every time, we can use this generic symbol for an angle and just say, and we're still going to say angle, just like we say ray when we see this, angle ABC, and we're still talking about the same figure. Okay, so that's one option for naming angles. Let's talk about our second option. I'm trying to scroll here a little bit. I know I'm losing my figure. Let's see if we can keep it on there. So this is still point A. So our second option would be to just use vertex, okay, to just use the vertex. And you're saying, well, why would I ever use the 3-letter one when I could just call this example, and you could use the same abbreviation, angle B, why would I ever call this angle ABC? This one's kind of got like a caveat. We can only use if there's only one angle with that vertex. So for us, it is applicable. How many angles do we see in our figure here? There's just this one angle. There's only one angle with the vertex B. So I would say absolutely if we wanted to, and there's no reason that we wouldn't, just to call this angle B, we would totally be correct. All right, so that's an option, but you can only use it, like I said, if there's just a single angle with that vertex. So we'll look at an example here of when really we can't use that. So same kind of letters, and I'm trying to mix it up, but name the 3 angles in the diagram is the example. So proper abbreviations if we want to use it. So initially, a lot of people only see 2 angles. I think these 2 kind of smaller ones. Remember, here's my vertex, but there's multiple angles with that as its vertex. So one example of an angle that I see on the board here is angle ABC. All right, so angle ABC is definitely an angle that's going on there. It's got the vertex in the middle. I could have called it CBA and still been correct. A second angle I see here is angle CBD. So I'm just kind of listing them out here. Angle CBD, could have did it backwards and done DBC, would have been correct. Where's my third angle? So our third angle is this, the larger one, the kind of the biggest angle up here. Let's switch this over to red. If I highlight the angle ABD, we're talking about a different angle. That would be different. It's kind of the combination of the 2 smaller ones. So angle ABD ends up being our third angle up there. Could have called it angle DBA and still been correct. I think this is a great illustration of why we have to use 3 letters to name it. By using those 3, we can be very specific. Do I want to talk about the small angle, or the big angle, versus just saying angle B? You really wouldn't know which one I was talking about, right? There's multiple angles with that vertex. Okay, so that's hopefully some clarification as to when we can and can't use the single letter abbreviation versus having to use the 3 letters. Okay. All right, let's keep it moving. Remember in lesson 1.2, I believe it was, when we talked about the ruler postulate, we have a very similar postulate here coming at us. Add this to our notes as far as the protractor postulate. All right, it's a very wordy. Remember, our postulates just mean kind of facts or statements that we assume are true but can't officially be proven to be true. So I'm not going to read it here, but it's essentially kind of saying that an angle, all right, we got a raise here, OA and OB, making up our angle. We can measure that angle and assign a value, a real number to it, anywhere from 0 to 180. And our unit would be in degrees. Okay, so this is a protractor. I'm assuming a lot of us have seen that in the past. I think the big takeaway here, all right, is this idea of measure of an angle. So the measure of angle AOB is equal to, and it gets a little bit wordy and technical, is equal to the absolute value of the difference between the real numbers for ray OA and ray OB. Okay, so ray OB has got a value of 0. You can see it here. And ray OA has a value of 140. Even that is kind of like, wow, what's going on there? So first things first, let's talk about measure here just to kind of hopefully clarify a few things. Measure is talking about number. So what we're looking at here is we have the physical angle AOB, which we can highlight and just point it out. Okay, here's angle, just what we got done talking about. AOB, that's the physical piece, the actual angle itself. If I want to start talking about the measure, the number value of that angle in degrees, I have to add a symbol to this. Before we move on, this is our physical segment. Let's just write that out. I'm sorry, not segment, but physical angle. And then the comparison is, if I add one little letter, the M, the measure of angle AOB, that's referring to what we're talking about here, that absolute value with the difference, but the number that we're reading from the protractor. Okay, that number from 0 to 180 degrees. the numerical value, I'm just going to use number symbol, the numerical value of the angle measure. Okay, so it's a difference of one letter, but we got to be careful as far as what we're talking about. If we want to talk about, we were just doing all those examples of the physical angles. Here is angle ABC, here is angle CBD. When we want to start talking about the numerical values of those measures, we got to add this little m. Okay, so for the example that's illustrated here, just going over how to read a protractor, we're looking at, I've got my ray right here, ray OB. Usually you would line up one of your sides of your angle with 0. There was a 0 right here. And then I'm reading from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, all the way over to 140. Okay. So to kind of just wrap this up here, we would say, if we were writing it, the measure of angle AOB is equal to 140 degrees. And there's us assigning a real number value to the measure of an angle. Okay. So kind of a lot said there, a lot written as far as the postulate. The big takeaways are using this symbol when we're talking about the number value, and essentially kind of how to read a protractor, how to use a protractor. Yeah. All right. Next note, so pause, add anything you need to add there. The next note is classifying angles by their measure, classifying angles by measure. A lot of these, again, I'm assuming we've had some exposure to in previous courses, or at least that's the expectation coming in. But we'll review them really quickly. An acute angle, let's just use M to symbolize measure, or let's say angle measure. We'll use just a little angle M for angle measure, because then we can be kind of concise with this, that an acute angle has a measure that is larger than 0 but less than 90. Okay, it's got to be somewhere in between for an acute angle. The measure has to be between, it has to be greater, it can't be 0, it can't be equal to 90, it's got to be somewhere in between. For our right angle, all right, you can see the symbol here that we'll use for a right angle. Our measure of our angle is exactly equal to 90 degrees. Very common angle we'll work with. We'll work with a lot of right angles this year. Obtuse angle, that puts us at a measure that is greater than 90, but there's still a restriction here, still less than 180 degrees. All right, it's not just infinitely beyond 90, it's less than 180. And this is, I'm assuming for a lot of us, a little bit more of a newer concept. You don't see this one as much, a straight angle, right? To us, it looks just like a line. And for the most part, we would probably more efficiently call this a line. You know, if I had another point to name it, line AB, or if there was another point here. But this is where our measure of the angle is exactly equal to 180 degrees. All right, so really 4 different ways to classify an angle. Acute, obtuse, right are probably the most commonly recognizable ones. Straight angle is also one. The measure of a line essentially would be 180 degrees. All right. So here's how we're going to use protractors. You can see I've got a protractor here. We're not required. I'm not going to have you measure. We used to do it, so I would kind of go through and show you how to use your protractor here at this point. But just the way the class is structured, not required due to time constraints and just not able to get there. I wish we could, but one of those things that we kind of had to cut. So here's how we're going to use them. Is it the best? No. It still gets us a little bit of exposure. It's a printed version of a protractor, and I'm still asking you to read angle measures, but they're already on there. Okay. So a couple different things going on here. Example 2, find the measure of each angle. So we got to be able to accurately identify the angle that's being described, and then classify each angle as far as, is it a right angle, is it obtuse, acute, or straight? Okay. So let's go through. I like to highlight them just so I know exactly what I'm talking about. So going back to how we name and talk about angles, angle GHK, let's find it. Angle GHK is what I've kind of highlighted in purple here. So what is the measure of this angle? So same idea, that I would be kind of starting here at 0. So I'm working with these outside numbers from 0 all the way over to, looks to be about 125 degrees. All right, so the measure of angle GHK and I want you to use that abbreviation. The measure of angle GHK is equal to 125 degrees. Notice I didn't just say, and I'll erase this here because this is incorrect, GHK equals 125. That's a kind of a nonsense statement. You're saying angle equals 125. We want to be talking about the measure here. So just to maybe reiterate that point of make sure we include the measure. To classify it, now that I know it's larger than 90 degrees but less than 180, this would be an obtuse angle. All right, I'm going to clear this off here, and let's look at our next couple. So that's the process here. Angle J, where is it? J, H, L. So again, if I'm starting at 0, I'm working with the inside numbers now, working myself over to this one. It looks to be exactly 90, so the measure of angle JHL equals 90 degrees. That makes this a right angle. All right, one more, clearing off. Let's find, I like this last one. It's a little bit of a different look, probably not how you would traditionally measure an angle, but if I look at, I can still find it, the measure of angle L. So L, H, K. I'm kind of just going in order of L, H, K. I got to be a little bit careful. I'm really looking at the difference between the two numbers. It really doesn't matter if I work with the inside numbers or the outside numbers, but just stay consistent. So I'm looking for the difference between 90 degrees and what looks to be 55, or the difference between, or the absolute value of the difference between 90 degrees on the outside. You know, that's not a very good line. The difference of between this 90 and this what appears to be 125. So I think we're talking about a 35-degree angle here. All right, so the measure of angle LHK is equal to, where again, where is that coming from? I'm doing one, take your pick. I'm going to do maybe 125, because that's, look where this one ray is measuring 125, and then subtracting the 90 that's right here and getting 35 degrees. Again, I could also go 90 minus 55, because I'm using the inside numbers, and still be at 35. That makes this an acute angle because it's between 0 and 90. All right, so that's the type of question involving measure and protractors, and then also classifying angles. All right, let's keep plugging away here. We've got a little bit more to go, actually a pretty fair amount to go. So next up would be our angle addition postulate. I've got a brief review here from previous. This is in your notes. It's a review. We did stuff with what's called the segment addition postulate. We made a picture in class that said, essentially, if I've got a segment broken up into maybe two smaller segments, we wrote it as, hey, the length, remember abbreviations, just a good review for us, the length of AB plus the length of BC, whatever those numbers are, has to be equal to the length of AC. And just about everybody said, yeah, of course, that has to be true. How could that not be true? This length plus this length equals the big length. That's what the segment addition postulate said. We're essentially bringing that exact same concept over to angle measures. So what we do, or what we did in class, we made a similar picture. Again, it's pretty wordy. I think a picture is very helpful here. Let's use, maybe even shorten it down a little bit here. So what we made in class was we drew an angle. We can go with our old friend angle A, B, C, and said, hey, we've got a ray here in between, ray BD. All right, splitting it up into smaller angles. So we end up with three angles like we saw in that first picture. What has to be true about what's going on here? The fact that this measure, the measure of angle ABD, it's a little bit longer to write because we're using a lot more letters, but a measure of angle ABD plus the measure of angle, where's my other angle here, DBC, when I add those together, measure of angle DBC, we should be equal to, and I did run out of space, the big one, the measure of angle ABC. Okay. I think it's one that looks more complicated than it is. You see this, sometimes we get scared away. It's really saying this angle measure, whatever it is, plus this smaller angle measure, whatever it is, when I add those two together, that should come out to equal the large angle measure. All right. So let's take a look at an application of our angle addition postulate. I've got a figure here, a couple different angles, some expressions representing their angle measures, 4x minus 1, 4x plus 4. I do have to use, there's some given information written out here that's pretty much necessary for this problem. The common mistake here, just to kind of see, we talked about it in class, I cannot set this up, so do not write this, but I just wanted you to see it. Why would this be incorrect? A lot of people went with that initially and said, hey, 4x plus 4 has got to equal this. They look to be about the same size. You know, this angle and this angle over here looks to be about the same. But the problem is, I don't know that. We would have to be told that information that, hey, you know what? The measure of angle GFH is the exact same as HFJ. Then we could go down that road. So I need a different setup for this one. Let's use that angle addition postulate. Why don't we say the measure of HFG, which is 4x plus 4, when I add that to the other angle measure, the measure of angle HFJ, this one right here, which is represented by 4x minus 1. You're asking, well, what happened to those parentheses, Mr. Kroll? The reason there's parentheses here is it's just it's trying to show that these are grouped, that this degree isn't just being applied to the one, it's being applied to this whole expression. This is just representative of some degree measure. So it's not like I'm just ignoring them, but when we go to kind of work with them, we can essentially kind of drop them for the sake of the problem. So yeah, that's what's going on there. Last thing, so what's going on? If we add those two together, we should be equal to the sum or the measure of the big angle, which we're told, and here's kind of the kicker to the problem, find the measure of GFJ, or tells us that the measure of GFJ is 155 degrees. So that's where we're going with our algebra for this particular one. All right, I've got some like terms to combine. We'll go quick here. This is just an algebra review. I've got an 8x, so I can turn that into an 8x. I've also got a plus 4 and a minus 1, so I think we can turn that into a plus 3 here, equals 155. We'll subtract this 3 from both sides to get 8x equals 152, and we'll divide both sides by 8 to get x equals 19. Okay. Now, by itself, x equals 19 doesn't mean a whole lot for us. Let's make sure we go back and answer the question as far as what were we trying to find. It was asking us for each individual measure. So the measure of angle GFH, how are we going to find that? Where's GFH? First of all, GFH is right here. So I'm going to take this 19, make sure it gets in there. So we'd just be plugging in 4 times 19 plus 4 equals 80 degrees. All right, I'm on board with that, 80 degrees. Our second one, we have some options as far as how we want to find it. I could definitely take the 19, plug it in over here. The measure of HFJ is equal to, let's see, 4 times 19 minus 1, 75. I think maybe even quicker, as long as I'm comfortable with this, and that's 19 being okay, I might just go 155 minus this 80 to say that, hey, you know what? That has to be a 75-degree angle. And I think we answered our question. There's our final. All right, so there's an example of how we might use that angle addition postulate. All right, two last concepts here. Congruent angles. All right, so with congruent angles, we've seen the tick marks before used in segments. So if I had segment AB, this is another review for us, but if I had segment AB and I wanted you as a reader to know that I mean that to be the exact same size and shape as segment CD, I would use tick marks. Could be 2, could be 3. It doesn't necessarily matter. It's just showing that we want those to be the same. Okay. The exact same concept can be applied to angles. Okay. Just slightly changing our marking. So if we have, let's just call this, for the sake of it, given a vertex and call this angle B, right? And I've got a separate, could be just hanging out over here, angle C, and I want you as a reader to know, hey, these angles need to be congruent, or I mean for them to be congruent. Right now, they're just a couple random angles. I use little arcs. This is the equivalent of the tick marks on segments. Okay, so we could definitely say that angle B at this point is congruent to angle C. Therefore, this also connects to measure, that the measure of angle B is equal to the measure of angle C. You really can't have one without the other. And it's a two-way street there. If we knew two angles had the same measure, 30 degrees and 30 degrees, I would know that they're congruent, okay? Or I could say, hey, they're congruent first, and then maybe later find the angle measures to be the same, okay? So a real quick example here is identify all pairs of congruent angles. I'm just looking at the markings to tell me that. So I can see very clearly here that angle L is congruent to angle M, just purely on the markings. And I can also see that angle P is congruent to angle N, just based on these being a single arc and a double arc, okay? If we were given information that the measure of angle P equals 120 degrees, we just talked about it. Well, I would also know that the measure of angle N has to be 120 degrees. So we would just follow up and say the measure of angle, N equals 120 degrees. So kind of a short, sweet example there for us. Last concept, a little bit longer of a lesson, like I said at the beginning, but I think we're getting there. I think we can just about check everything off our list. Segment bisector. All right, one last review for us, right? It was anything that passed through the midpoint, basically cut. What did bisect? We said cut something directly into two congruent parts, cut it in half. So a midpoint falls into that category, but also a line, array, a segment. So we can cut a segment essentially into two congruent parts. AM is congruent to MB. Just carrying that concept over to an angle. Okay, an angle bisector is just another ray, so ray DB in this case, that divides the big angle ADC into two congruent angles. Now, right now, I don't know that that's an angle bisector, but if I add my markings and said that, hey, angle ADB is exactly congruent to angle BDC, then therefore we would know for a fact that ray DB is an angle bisector. All right. So last example that relates to our angle bisector. Actually, there's two of them, a kind of a short one and a little slightly longer one, if we can get there. All right. In the diagram at right, I'm reading here, ray WY, this is a huge word for us now, bisects, cuts in half, angle XWZ. So it's getting cut in half. A little bit redundant here. It's given us these markings to just indicate that, hey, they're the same. I can add double arcs. It doesn't necessarily matter. What are we told? We're told that the measure of angle XWY, so this one here is 29 degrees. Find the measure of, just be careful here, XWZ. So it's actually asking us for the whole thing. So I got to be careful. Don't just say 29 degrees. We should know that these two smaller angles end up being 29, but the measure of angle XWZ, the whole big one, ends up being 58 degrees. All right, so another kind of short and sweet one there. Last example here, trying to wrap it up, keep it semi-reasonable as far as time-wise. In the diagram at right, same word, BD is bisecting the big angle, okay? So algebra-wise setup, now I absolutely can say that negative 4x plus 33 has to be equal, that measure has to be equal to this 2x plus 81, okay? Because we know that this angle and this angle are congruent, all right? So algebra-wise, setting it up, we are going to end up, I'm going to subtract a 2x from both sides to get a negative 6x over here, and then I'll bring the 33 over, so 81 minus 33 ends up being 48. Whoops, where did we go here? 48, sorry. And then I'll divide both sides. I know I'm not showing every single step, so I would encourage you to. I'm just trying to make the lesson manageable here for us as far as time. X equals negative 8. All right. Now it's kind of a weird angle, or it's not an angle measure, but it's a weird X, right? We're used to X being a positive number. We'll see here. I think everything's going to work out okay. We wouldn't want to plug this in, and if we did plug this in and get negative output values for angle measures, that really wouldn't make sense because we said they should be between 0 and 180. But I think because of this negative here and what's going on with this 81, I think we're going to be okay. So I know I kind of jumped in and got going really quick there, but we had an angle bisector. It was a similar setup. We're setting our expressions equal to each other. Let's finish this up. Find the measure of angle ABD. So that's this one right here. I'm going to take this negative 8, plug it in, the measure of angle ABD, and ABD is equal to negative 4 times negative 8, which is positive 32. I'm kind of crunching that number in my head here. I know there's not a whole lot to see. Negative 4 times negative 8 is positive 32 plus 33. Yeah, we end up with a value of 65 degrees. So I'm okay with that. It makes sense. I think it's a reasonable angle measure. Now I should be able to, without even plugging in, know what the measure of angle CBD is, because these should be the same. Now, I am going to confirm it. I want to make sure, if this is my work and I made a mistake, so I'm going to go 2 times -8, which is a little bit weird there. And you're like, oh, -8, is this going to work out? But then what are we doing? We're adding 81 to that. So absolutely, it does work out to 65. So that's kind of what we expected to have happen, that these would be the same. The last one, there's not really anything, if we're looking for the measure of the big one, measure of angle ABC, there's not really any expression to plug them into. I just really need to sum these two values. Okay, so 65 plus 65 is 130 degrees. And I think we've met our requirement there. Okay, we've found all 3 angle measures. So that's a little bit long of a lesson, right? A lot of vocab, 6 different examples there going through. Let's just go back and recap. Did we hit all our goals? Definitely name, measure, classify angles. Right, obtuse, acute, straight angle, identify congruent. We talked about using the arcs to illustrate congruent angles. Couple different, well, really one big example using the angle addition postulate. This plus this equals this. The small angle plus small angle measure equals the big angle measure. And then we looked at angle bisectors in a couple different spots here. So there's your notes for lesson 1.5. Give the homework a good effort, and I will see you in future lessons.